continue to narrow my focus toward the formulas that are listed in the chapter 12, Miller's chapter 12. Um, I'm going to start very broadly though. As I work toward that, I'm going to start with I believe it would be called a metaphor because I don't know, it seems to work well. Uh, all of us have been kids, and I'm 100% certain of that. And I'm fairly certain that every one of us, when we were kids, had the experience of going to a pond or a stream or a body of water and throwing rocks in. That is just what kids do. And, it's pretty cool. It's still pretty cool. But when you're just exploring life, first experiencing things, it's real cool. And suppose now, when we're doing that, we do, as kids often do, we start to make it into a competition. We could be trying to get the biggest splash we can as an individual, or maybe if we have multiple kids sitting on shore throwing rocks into a body of water, they start competing with each other, because that is what kids do, by my experience anyway. Now, what this would lead us to is pretty soon we would need to establish some rules around this game, as has to be done if we're going to start making things into a competition, right? And so we would have to start thinking about, if we're going to say who has the biggest splash, we need to define really kind of what that is, right? Because when we throw a rock into a body of water, here comes the rock. That's the rock. Obviously, that's a rock. Gravity has it going downward, so it must have been a rock. Splash. There is the splash into the body of water. Now, the kid who does that, who has a very tall splash, says, look at that height of that splash, I won. Then another kid throws his or her rock in and says, what? Yeah, but look at the width of my splash, I won. It's a fair argument. And then another kid says, no, you're both wrong, because my rock, the way I threw my rock, it made huge waves that rippled all the way through the pond and was still making waves to shore, and neither of yours did that. So when we're discussing the Keynesian multiplier effect, what we're really going to be doing is trying to answer that question of how much total displacement does an initial event do. The initial event is dropping the rock in. After we account for a Keynesian multiplier effect, what we're trying to find is how much displacement did the initial event cause, except we're not doing it with rocks and water. That would be more fun, probably. We're doing it with graphs and formulas. So I'll just stop this little piece, and that's what you have to look forward to.